Hello everyone, this is Doug and I'm ready to do your week 9 MyStatsLab problem 7 example. Store owner surveyed 25 randomly selected customers and found the ages shown in years. We have those here. The mean is 30.04 and the standard deviation is 9.48. The owner wants to know if the mean age of all customers is 37 years old. Okay, so we have all of the ages from the randomly selected customers here, and that gives us a mean of 30.04, as I just stated, and a standard deviation of 9.48. After that, we really don't need this list of numbers. We're going to answer some questions here for this problem, and everything else we need is within the problem, or we'll make it ourselves. So part A, what is the null hypothesis? Well, our null hypothesis, which you already know, is noted here with an H sub O, and this is used to specify the population model parameter. In this case, our null hypothesis is what the owner wants to know is if the age of all customers is 37 years old. So we're going to make that our null hypothesis, where we're going to insert. Let's go over here and pull a symbol out. I think I showed you this on an earlier video. Use that for our mean equals 37. So our null hypothesis is that the mean is 37 years old. So that's part A. And part B, is the alternative hypothesis one or two-sided? Well, how do we determine that? We're going to look at the problem here, what it asks us for, and see if that helps us out. Alright, the owner is interested in knowing if the mean age is 37. So the other side of that is it below 37 or is it above 37? So that tells me that this is a two-sided problem here. I mean, it could be below 37, it could be above 37. So we're going to be looking at both sides of that. So that tells me 2 is the answer there. Okay, so what is our alternate hypothesis? Well, in this case, if it's our hypothesis for the null hypothesis is 37, then our alternative hypothesis is going to be basically that the mean is not equal to 37. So let's insert mean, insert a not equals, close that off, and then we can put 37 again. So there we have it. The null hypothesis is the mean is 37 years old. Our alternative hypothesis, which is two-sided, is that the mean is not equal to 37. Alright, let's move along. Part C. What is the value of the test statistic? Alright, well, we need to do some calculations here. We're going to need some information to help us do that. And I have most of it here. So the first thing we're going to need to know is the mean, hypothesized mean of our problem. So in this case, we're talking about 37. Alright, how about y bar? Okay, the sample mean. What is that? Well, in this case, we're going to say what the problem told us was 30.04. So 30.04. So our hypothesized mean, what we're looking for in this problem, 37, because that's what he wants to know. Our sample mean from our sample here of all the numbers is 30.04. Our standard deviation here, given in the problem, 9.48. And we also know you need to know n. And in this problem, we surveyed 25. So n is going to be 25. So there's everything we need to go ahead and calculate and find out what our t statistic is. Now if you look at the formula for that, y bar minus the mean divided by the standard error. Alright, we've done standard error before, and here's the formula here. To find the standard error of y bar, we're going to take this standard deviation that we have and divide it by the square root of n. So let's go ahead and do that and get that part out of the way. So we can make our formula equals, and we're going to take our standard deviation here and divide it by, and again we can use the square root within Excel, so I can start typing square root. There it is. I'll double click on it and it asks me to put the number in there. That number is 25. We'll close that parentheses and hit enter, and there is our standard error, 1.896. Now this makes it a little bit easier to go ahead and find the formula for our t statistic right here. So now we can simply go equals, and we'll put the top part in parentheses, y bar minus our hypothesized mean there in parentheses, and we're going to divide that by the standard error, which we've already calculated here. Just hit enter, and there you have it. The test statistic for this problem is a negative 3.67. So let's move on to part D. What is the p-value of the test statistic? For this, we're going to need degrees of freedom. And I put the little formula here, quite simply, n minus 1. So I can say equals, and n right here, minus 1, and enter, and of course 24 is our answer there. So now we have everything we need to find the p-value, and for the p-value we're going to let Excel do it with a formula called tdist. Tdist asks you for the degrees of freedom, our x, which will be the t statistic here, and in this case we'll use the absolute. It won't be negative, and we also need to know whether it's a one or two-sided test, and we've also calculated that also. So let's go ahead and put this in and start typing equals tdist. There it is. Double click, and you see it asks for x, degrees of freedom, and tails, with a comma in between each one. Well, x is going to be our test statistic, and I said again, this will be an absolute of that. We won't put it in as negative, so we're going to enter 3.67. Then we'll use a comma. It asks us for the degrees of freedom, which is right here. Another comma, and it asks us for the tails. In this case it's a two-sided, so we're going to have two tails. So I'm going to put a 2, close my parentheses. That's all we need. Hit enter, and there you have it. There's our p-value, 0.0012. There you have it. You've done all the math for this problem. We only have one more part to look at. Part E asks us, what do you conclude at an alpha of 0.005? And you say, see, I have written here, if the p-value is less than alpha, if this p-value, which is 0.0012, is less than alpha, which is 0.05, then we reject the null hypothesis. On the other side, if the p-value is greater than or equal to alpha, then we fail to reject the null hypothesis. Well, in this case, alpha is 0.05. Our p-value is 0.0012. So, what does that tell you? I think you know the answer there. So there you have it. That is our Week 9 MyStatsLab Problem 7 example. The good thing here, we did a lot of math, but you can play this backwards and forwards as many times as you like. You can listen to me. I know I'm a lot of fun to listen to. But you can go back and forth. The formulas are here. Take a look at it, rewind it, take a look at it again. But this problem worked out very nicely, so there you have it. There's your Problem 7 example from Week 9 in your MyStatsLab homework. I'm Doug. See you later.